So we're asked to find the surface area by revolving this curve around these two x-coordinates, sorry, between these two x-coordinates around the y-axis. So you could draw it. X is 1, x is 64. Cube root, what does that look like? Well, this is 1, this would be 1. If this is 8, this would be 2, because that's the cube root of 8. So it should look something like this. We're revolving this surface, the curve around the y-axis, so I think it's going to look something like this, where you take this shaded region and you revolve around the y-axis. So that's just a quick visual of what we're trying to do. To actually make the calculation, our textbook derives a formula for surface area. Note everything is in terms of y when we're revolving around the y-axis. This is in terms of x. So we want to cube both sides. So x is going to be y to the third power. And so when we make that switch, that's going to change. Instead of integrating between 1 and 64, we want to integrate for the y coordinates. If you plug in 1 into this function, you get out y is 1. So y is an element of the interval from 1. And then if you plug in 64 into this function, the cube root is 64. If you have a calculator like this, you could do 64 to the 1/3 power. So 0.33333333. So that's 4. So that's the change. We changed the variable, so we had to change from x to y's for our integration. So following the formula, integrate from 1 to 4 of 2 pi and then g of y. We just change it as y to the third. And it's a cube root of 1 plus the derivative with respect to y. So that would be 3y squared. And then we square that result. So 3 squared is 9. Y squared squared is y to the fourth. And then dy. Okay, so I think this is an integral we could do with u substitution. We can factor out this 2 pi. That's one step. We get that u be 1 plus 9y to the fourth. That means du is 9, 18, 36y to the third. So we don't quite have du. This would be our u. We need to substitute all the y variables in terms of u. So we need to have a 36 out front, so we'll factor out 1 over 36 to the side. So that's a 36 here, 36. Because if you were to multiply those, brings us back to where we started. So this is du, this is u. So it's pi over 18, 1 to 4. This is square root of u du. So, sorry, it's not 1 to 4. Got to cancel that out. You can write 1 to 4 later. 1 to 4 was in terms of y. So if you really wanted to put limits of integration in here, you'd have to make another change it in terms of u, which gets a little complicated. You have to plug in 1 in for y, solve for u. I guess that's fine. You could do it that way. That'd be, what is that? Plug in 1 in for y, you get 10 for u. And then plug in 4 in for y, you get a huge number. I'm just going to wait and put it back in terms of y and then put my limits of integration in. So this is u to the 1/2 power. That means the power is going to increase by 1. But when I find an antiderivative, I need to multiply by the reciprocal of the power. And that's not plus an arbitrary constant c because we have limits of integration. So let's put it back in terms of y, and then we can substitute our limits of integration. U was 1 plus 9y to the fourth. That's all to the 3/2 power. And we were integrating between 1 and 4. We can put the 1 and the 4 back in because it's back in terms of y. So we got 2 pi here. This simplifies. So we got pi over 6. And then if we plug in 4 to the fourth times 9 plus 1. And then this is to the 3/2 power, so it's the 1.5 power. Let me see what WebAssign wants here. So when I looked, WebAssign doesn't want decimal approximations. That would be way easier if we could. So I got 2305 to the 3/2 power. And whoops, I got to make sure everything's being multiplied by that constant. If I plug in 1, that's 9 plus 1 is 10, so we got 10 to the 3/2 power. I think WebAssign might stop and accept this as correct. We could rewrite it a little bit more. I don't see how it's going to make it look that much nicer though. So if you got a 3/2 power, let me try plugging this in because it's just a useless algebra exercise to keep writing it. So let me check to see if this is right. So here's how WebAssign rewrote their answer a bit. Same thing. Look, this is a 1/2 power times times something with a 1 power to add up. So this is a square root of 2, 3, 0, 5 times 2, 3, 0, 5. That's a 1/2 power plus 1 would make 3/2. And same thing over here. You get square root of 10 times 10. Okay, that's the format WebAssign wrote their answer in. Let me check. Yeah, okay. So one last quick note. This is pi over 18. It looks like I wrote pi over 4 at some point, which is not correct. So that'd make 9. So this should be a 27 on bottom. Everything else is right. Just I dropped a constant there.